Hello, my name is Dr. Marty Martin, and I'm a faculty member at DePaul University in Chicago, where I primarily teach in the area of health sector management and actually direct the MBA program in health sector management. But enough of that. So what you're really here for today is to really focus on a tool for quantitative decision making. And the tool that we'll go over is called time series analysis. So whether you're just focusing on this tool or really looking at the whole series is really not important. So let's begin to dive into a time series analysis. So when you think about it, this is just one tool within a whole portfolio or within a larger toolbox. So you want to be able to know, when do I use this tool? And also you're also thinking about other tools as well. So let's talk about time series methods. So in essence, what it is, if you think about a series that suggests multiple data points, more than two, but could be 400, yep. So anywhere two to upwards to thousands, if you will. So that's a series, yep, or a trend. Time means that it's over a time period. So it could be within a 60-second time period. Think about your pulse. That's within 60 seconds. It could be within 10 years. Think about the census. So you have to select your time frame and then the data points of relevance. What also happens too when you do a time series analysis is there are four ways of looking at it. One is the trend. Yep. So the trend is what's the relative up or down in the series. So if you have a temperature, yep, so there's a range kind of hovering around 98.6. Hopefully you don't get too large of spikes or it doesn't drop too far below. Seasonality. So there's the cold season, the flu season, yep. Then you have cycles. So think about boom-bust cycles in terms of the stock market, boom-bust cycles in terms of industrial output. Then you have randomness. Yep. So when you're looking at a time series analysis, these are the basic types of series that you will see. Now I want to begin to take a look at four different patterns or relationships that you may see. So the first one, if you will note, in that upper quadrant there is purely random. So there's really no recognizable pattern. If you kind of flip right over, then you see a linear trend. That's the straight line. Yep. So as one variable moves, the other variable moves in a corresponding way. So that's a linear trend. Go to the bottom there, you'll see the curvilinear trend. And then the last one is really seasonal because you have those peaks and troughs. So this is just some example that when you begin to plot out data over time, how it reveals itself. Now, there's a particular technique that you want to look at. Yep. Because remember, you're going to have a lot of data. Yep. So you're going to have to make sense of that data. Let's say you have 400 data points. Yep. So what that 400 data points is, how do you make sense of it? You could do the mode, yep, which is the most frequently occurring number. You could do the median. So the median, if you remember from statistics, is you take the highest number, then you take the lowest number, and then you go right in the middle. So that's the median. Or you can take the average. And if you remember from statistics, is for the average, if we have 400 data points, we add them all up, and then we divide by the total number of data points, which in our illustration is 400. That's another way you could work it. But I'd suggest that you use a method called an moving average method. What is a moving average method? So what that is that over time, the last number that you collect is added in, but the earliest number is dropped. So a moving average, as things change, you're adding the new things and you're dropping the old things. So it's kind of a moving trend. So it really enables you to keep pace with changes. So you can note here some advantages as well as some disadvantages for moving averages. Now, one of the things you have to be concerned about when you do a moving average, as illustrated in this graph, is you have the moving average for 3 months, MA3, and you have the moving average for 6 months, MA6. If you note, they are lagging behind the actual demand. And that's important to note because, say, for example, you have an inventory of pharmaceuticals or an inventory of surgical supplies. So when you're actually using these moving averages, that may actually lag behind the actual demand, and you could actually have some shortages. So that's something to keep in mind. Now let's take a look at how do you actually calculate a moving average. So if you note here, we have the month, so January through June. We have the demand. January it's 89, and in June it is 280. And then if you flip over, we still have the month and the demand. So how would you calculate the 3-month moving average? So if you know, what we're going to do is we're going to look at October, and demand in October is 275. Look at demand for November, that's 188. Look at demand for December, that's 312. So you add those up and you divide by what? 3. And the math should work. Check it out, and if it doesn't, email me at martym@depaul.edu. And then for the 6-month moving average, you do the same thing. But we're going to begin at July and go through December. 12-month moving average, do the same thing. Begin at January and then go to December, but divide by 12. So what's the 4-month moving average? So we're going to go look at December, November, October, September. Add all those numbers up, 212, 275, 188, 312. And we're going to divide by what? 4. Pretty simple. Yeah. So when you're thinking about a moving average, if you note, you can also select a time frame. It's as simple as that. Don't make it more complex than what it has to be. And please don't tell me, hey Marty, I'm no good at math. That's just simple arithmetic. And if you can't do it by hand, use a calculator. So the next tool that I want to introduce is called Statistical Process Control. That's also going to use data, but it really focuses on something a little bit different than what we just talked about now, which is a time series analysis.